Okay, great, awesome. So this topic for today, why and how to invest in developer tooling, is one of those topics which has kind of shaped my career um, in IT industry. Well, I would like to discuss dig deeper into this topic, but before doing that, let me try to introduce myself. My name is Balraj Singh, and I have been in the software industry for almost 12 years and working as senior software engineer. From past 6 years, I have also worked extensively on an iOS development, and time to time I do full stack development too. So I have worked in companies like I'm currently working in Meta. Prior to this, I worked in one of the neo banks in Germany, and before that, I was back in India working for different kinds of startups like Ola, HelloDoc, Hike. So these are kind of smaller startups from where I have built up my career. Yeah, that's about me. I'll be sharing my LinkedIn profile in the last slide. Moving on to the next part, which is the agenda. Today's presentation I'll just try to simplify this by saying I'll try to ask why to invest. I'll try to justify why to invest in developer experience. The second topic, which I'll say, is how to find whether a particular problem is worth investing someone's time or not. And third is I'll try to showcase is what does it mean to improve a developer experience by showing a simple example. Moving on to the why part. Now, this is a really important question. Why? Why should we invest in it? Well, I'll start by asking a much more practical question of how to save hours of development time every week. Now, when I talk about development time, it means that we are not just talking about a single developer, but a team of developers. And if you are able to save time for each and every developer, the impact of the solution multiplies. And with the growth of the team, like let's say if your team is increasing in number by let's say 10 engineers more, you have already solved that problem for those 10 engineers and saved that time. So I believe this becomes a really multiplying factor of when you have been able to target a particular development experience problem and solve it. It grows very fast. Now, the other thing that we should all think about is that over years of experience in building products, building features for company, you know, every engineer hits a particular point of time like in the entire engineering experience. There is a particular point of time when people think, how should we grow more? Where can we like how can we grow more? Either an engineer becomes try to go on a path of becoming manager or in that direction, and if he is a hardcore tech savvy person, then it really becomes hard to just grow yourself by building features. You can learn as many languages as you can, but then what you are actually doing is just trying to improve your skills. And that is a really slow process with time. What I generally try to do is um, I try to think, how could I impact other developers? How could I improve other developers' life in my team? That really helps me to showcase my work, my impact of my work in multiple folds. And this is where we start talking about developer experience. Now, if I'm able to solve a problem, a developer experience problem, then I'm saving every engineer's time in my team and hence giving a lot bigger impact rather than just sitting back and implementing features. So I believe this is a quite a motivating factor for an engineer to work on, like help other engineers to basically let them do their work much faster, much efficiently, and so on. Moving to the other part, like benefits of good developer experience, like you can focus majorly on your business goal, your user experiences, instead of thinking about like at times, like back in my career I used to always think about how should I implement a particular. When we start asking about how should we implement a particular feature, I believe that's the time when we need to think about that, is it so tough to implement this particular feature, or is there an issue with our developer experience? Can we kind of improve ourselves to move faster? Can we work smarter, not just harder? And I always feel that if we continue to write more and more code, we tend to make mistakes. And That's the reason I try to automate as much as possible by, you could say, introducing code snippets. That's one very basic thing that we all can do is start writing code snippets. I have hundreds of code snippets in my IDE that I work on, which helps me to write every code faster with less mistakes that I can. And an efficient workflow, that's also very important. Having an efficient workflow helps me to not think about how to implement certain thing, but it helps me to keep my focus on what I am doing, how to solve a business goal, how to solve users problem. That's where I try to spend most of my time. And having a good developer experience kind of motivates you to do that. So I find this is quite important. This is very motivating for me. Moving on to the how part, after like thinking about why, how, like how should we think about a particular problem is worth investing our time or not. I would say, how can we improve developer experience? Let's start with what are the areas that we can focus, and then we'll move on that whether these what are, like, in one of these areas, if we think that there is a particular problem in our current company or in our team, then how should we determine whether that problem is worth solving or not. So when we talk about how, like, what are the areas we can improve with, obviously the first thing is app architecture. Like if you have an app architecture which is non-modular, these days you have composable modular apps, that helps a lot. Like in like every developer, to every developer, that helps a lot, building new feature much faster. Like you don't have to open up the entire application to test your particular feature, but you can just have this small module or small playground app attached to your feature and kind of do that iteration very fast of building up a new feature. The second is removing required manual steps. Now, we there are a lot of manual steps that we can remove. For example, one of the very simple thing is running code or running test every time for your feature before you are raising a pull request. That's something you can move into CI/CD pipeline. So you don't have to always run your test before you ship anything. You just move it to CI/CD pipeline. That will run tests for you eventually. Workflow and code automation. You can do a lot with code automation. One of the things which I said is you can always have code snippets. The other thing is you have these things like linter or code analyzers, which can always keep on running in your CI/CD pipelines. So all of this could be automated through one or the other way. Now you need to think where you need to put all these things. Building developer tools. Yeah, building developer tools is, you can think about how you can improve your development using Xcode if you're an iOS developer, or you can think about how you can use VS Code to improve the development experience that you are having. Correct. There are many improvements which have been done by, let's say, if I'm an iOS engineer, I would talk about Apple. Apple has made a lot of improvements in Xcode over time. Correct. But before Apple brought those experience, there are other engineers who has invested their time to improve those experiences even before Apple brought that. Shortening feedback loop. This is quite important. This is something which is quite interesting and important, which I'm going to talk in more details in later on slides. So shortening feedback loop is about, when you make a certain change in a feature and you build your application and you wait for it to build and see the result, how can you shorten that loop, or how can you shorten the loop of getting a feedback about whether you are breaking any test, whether your feature is impacting some other things or not. So all of this accounts for shortening the feedback loop. Once you improve this part of the developer experience, uh, I'm pretty sure that most of the engineers working in that team would be happy with this kind of improvements. Moving on to the next part on how to gauge if you should invest in this tooling. Now, there are a lot of ways to think about this. One is, let's say, if I face a particular problem in my day-to-day development, I would generally say, um, is that I will generally think in this way: is this a problem which is only like is this something which I am facing? Is this only limited to me, the problem that I'm facing, or is other peers or other teammates in my company who are facing the same issue? The way I generally try to understand, or I generally try to gather this information, is by either putting a company wide poll with all the engineers, or in my one-on-one with other engineers. And this is a practice which I generally do, is have one-on-ones with my peers, one-on-one with my manager, with other team members, and try to gather that information over there. So this practice of gathering information from other engineers helps me a lot to make this decision of, do I want to focus on this problem or not? That's one part of it. How big this problem is within the company, within your team, with across your team. The next important part is, how much time how much time would I be investing to solve this problem. Let's say if this problem is a real problem within the engineering community, within your company, within your team, but if you have to invest a huge amount of time, let's say it's a month project, correct, then it becomes really, important to understand that if it's so complex to solve, whether it will reap out the same amount of benefit for every engineers after spending 1 month. Will it drastically improve developer experience? Will it reduce time for development by, like, let's say a couple of hours for everyone in the team? So until unless it's not that big of a deal, I would generally try to say that this is not something which I want to focus on. But if by investing, let's say, a couple of days, if I'm able to solve a particular problem that saves an hour for every engineer per day, I would surely go for that, because 1 hour, one engineer per day would mean that if I have engineers, like a 10 engineers in my team, that means I'm saving 10 hours per day. That's almost like one single engineer work per day, even more than that. So yeah, that seems to be a good kind of estimate that I will do to pick up a problem which I want to solve. Yeah, so that's how basically I gauge whether I need to invest in a particular problem or not. Moving on to the example part now, we have reached to the example part of it. Now I want to focus on the particular topic of shortening feedback loop. This is quite important. If I pick this problem and try to see what I can do with this problem of shortening feedback loop, let's see what this issue is all about. This I have put up a small portrait over here. Shortening feedback loop is really important because, let's say, if as an engineer I made certain changes and I'm compiling the code now, for, let's say, it takes around 1 or 2 minutes to compile the code, build it, and basically deploy it. Then in that particular point of time, as an engineer, I generally lose my interest of what I'm doing. I get disengaged in what I'm doing, and in that particular point of time I lose focus. Now to get back that focus back to my work again, I'm kind of losing around not just those hours of building the app, but even for me to focus back into my project again, I'm losing a couple of more minutes. That means every time my build happens, I'm losing around 3 to 4 minutes of my time. And if in a day I'm doing this for around 100 times, like I'm building an app for 100 times, correct, that means I'm already losing a huge amount of time. So this becomes a really, I would say, important problem to look at. Just to put it in numbers, I would say, let's say time per iteration, that means time to build an app is 30 seconds. And number of times I generally build an app per day, let's say, for example, is 200. You can say it's 100 for someone, maybe 200 for others. So total time I would invest or I would waste just building that app with an iteration of 100 would be around 0.83 hours. That's in a single day. And if I'm kind of doing something very extensive and moving the iterations to 200, that's almost more than an hour and a half. uh, Now this may look very small, but in a single day, if as an engineer I'm investing just more than an hour to build the app, I would say that's the time I'm just wasting in sitting on my seat and seeing the screen, what's happening over there. And this is the time which I can improve, not just for myself, but if I improve for my entire team. Imagine a team of 5 or 6 engineers. That means everyone put together is going to save around 6 or 7 hours of total engineering effort. And that seems to be a huge amount because per day, 6, 7 hours is huge. Now, this interesting problem, how can I basically work with this interesting problem? The first thing that I would generally do is see if my project is built out of smaller modules or not. No, smaller modules not only helps you to improve your iteration cycle, but it also helps you to have this modular architecture. It also forces every engineer or every developer to think about the public APIs, like what kind of public APIs they wish to create to build up this module. And this becomes really, you know, a good way of practicing a good abstraction over modules that you're building. It helps you to detangle your solution project into smaller modules. Now, each module can be unit tested separately. Now, every module, when it has its own particular set of unit tests, then based on those unit tests, you can run those unit tests very fast in, let's say, in your CI/CD pipeline. And one other improvement with this smaller module approach is that when you CI/CD pipeline, when you create a diff, or sorry, when you create a pull request, and you basically put that out, your CI/CD pipeline can understand which modules have been affected by those file changes and only run those test suite for those modules, which helps drastically to reduce the test time that one is investing in a CI/CD pipeline. Also, we can say that we can have smaller playground apps. If it's an app, if it's an Android and iOS app, then we can say that we can have smaller playground apps. Now, what does this playground app does? It helps you to reduce your time to build the entire application, and it helps you to even have a faster logging mechanism and reach directly to your particular feature, through either, if you have a mechanism of a deep link or a universal link, you can use that to reach directly to your feature rather than building the entire application. So I feel this playground app, this smaller modules, this becomes really important, a keystone, or a key factor to improve your iteration cycle. Now, if your iteration, like, you already have smaller modules, you are already practicing playground apps, then what else can you do? Like, you may ask, what more can you do? I would say there's also a concept of hot reloading. Now, this hot reloading concept is something which is not new. Apple has already introduced in Xcode. I have been using one of the project called Inject for quite some time, and it has a great concept of hot reloading. Now, hot reloading, in case of Apple, when you talk about Apple, they have introduced with the Swift UI, and it's a part of your Xcode. The only downside to this is that, in case of hot reloading for Xcode, it would only you know work with static data. It's not going to work with anything else but static data. If you want data to be dynamic, and if you want something like to load network data, that's going to be really tricky to do with the in-house solution which Apple provides. So that's where this inject project basically helps you to um, solve your problem. Now, with this project, if you have integrated this library into your project, you can hot reload any screen that you want in real time, in a simulator, correct, and with the network data, with real data actually. And this is quite amazing. This is not just restricted to your Swift UI apps. You can do it with view controllers. You can do it with, let's say, you can also do it with Objective C code also. So this goes way back. um, and I can show you an example of what I meant by hot reloading. So moving on to the example part, here is a simple app where I have already integrated inject. The way I have done that integration of inject is I have just added a package of inject over here. The next thing that which I did was, in the build settings, um, I added a separate flag called xlinker, and I have installed. I have also installed a new app. It's not an app, but basically it's a package of inject over here. You can see this package of inject over here. Um, Now, when I run this application, so let's move to the screen. I'm running this application. You can see. over here. Let's wait for it to reload. Okay. Now, if I have to make any changes, let's say I'm making certain changes, and instead of Balraj, I will say this is an example app, and it's almost reflecting in real time, as you can see. So you don't need to rebuild an entire app. So most of this data that you're getting over here, you can, yeah, like you can also include network data over here. With the network data, it's going to basically change the only part of the app which is basically is where you are actually making the changes. It's only going to reflect that part changed. You can do a lot more with this. You can basically, I can keep playing with this. This is quite addictive, I would say. Let's say if I put this, yes, yeah, it's quite like a magic. And believe me, like I've been using this for quite some time, and it has helped me to save a lot of time. And I have also introduced this in my previous companies. Um, so I was like, this is how you can basically get faster feedback without building app. You have saved your, like, those 30 seconds have dropped down to, I would say, 5 seconds in terms of building up the project, loading those changes and everything. And yeah, so this is how you improve the iteration cycle, how you basically save time for developers. And now the time for Q&A. To let me know if you have any questions. You can write in the chat part or the Q&A section, and I'll be able to happy to answer all those questions. Awesome. If no one has any other questions, so I'll move to the last slide of thank you. Thank you everyone for joining today's session, and you can reach out to me on, like, on LinkedIn, and I'll be happy to answer any of your questions over there. Feel free to reach out to me. Don't hesitate. Thank you everyone. Thank you everyone for joining, and it has been a pleasure. Thank you.
Thank you, Hartak.
Bye bye.
Bye.